why does the rotation of the Earth slow down every year? That's a good question. Good question. Basic physics question. But how many? I mean, I'm glad people are curious about this. So let's take a look at the Earth. This is the Earth. It rotates. The sun rises in the east and sets in the west, which means it's rotating in this direction. You get it? It's rotating in this direction. That's how the Earth rotates. And what's the speed of the Earth's rotation? It's one rotation every roughly 24 hours, as we know very well. But here is the deal. See, the Earth is about 4.4, 4.5 billion years old. The solar system is 4.54 billion years old. So, when the Earth was a newly formed planet, incandescent, glowing with lava and whatnot, and with a very alien atmosphere, so that's about 4 billion years ago, let's say, 4.5. So, you go back to that time, the initial days of the new Earth. That time, the Earth's day was way shorter than it is now. It may have been about 6 to 12 hours long, probably around 6 7 hours long when the Earth was newly formed. It's 4.5 billion years before today. So the Earth's day was much shorter, and at that time the Earth was spinning much faster because of the initial angular momentum that it acquired during its formation as part of the protostellar disk that gave rise to the sun and the other planets and other objects in the solar system. So the Earth was spinning much faster because of that initial angular momentum it had acquired. Then, over billions of years, over the next 4+ billion years, the Earth's rotation gradually slowed down. And this happened because of gravitational interactions, mainly with the moon. And the mechanism of the slowing down was through tidal friction. And this still continues today. So it is believed that the Earth day, the period of rotation, it is increasing by about roughly 2 milliseconds every century, which is very slow, but it adds up eventually over hundreds of billions of years, over billions of years. So the rotation slows down primarily because of tidal friction caused by the gravitational interaction between the Earth and the Moon. So we know what tides are, right? The sea rises and falls periodically, twice a day, once, whatever it is, right? The Moon's gravitational pull on the Earth creates tides in the Earth's oceans. And this causes a bulging effect in the Earth's oceans. But the Earth's rotation causes this tidal bulge to be slightly ahead of the Moon. And then the Moon's gravity exerts a force on this bulge, creating a drag on the Earth's rotation. And this drag results in a very slow, gradual transfer of rotational energy from the Earth to the Moon. And as a result, the rotation of the Earth slows down. And also, it has the effect of having the Moon slowly drifting away from the Earth. About 3 4 centimeters per year, the Moon is drifting away from the Earth. So it is slowing down the rotation of the Earth. It is also causing the drifting away of the Moon from the Earth. And there's interaction with other solar system bodies, other celestial bodies. The sun also contributes to tidal friction, but the effect is much weaker than that of the Moon because the Moon is right here. It's right out here. So all that also contributes to the slowing down of the Earth's rotation. And then there is internal friction within the Earth's interior, movements within the Earth's interior, tectonic movements, the movements between the mantle of the Earth, the core of the Earth, that can cause energy dissipation, which can cause changes in the rotational speed of the Earth. Then there is atmospheric movements and oceanic movements. All of these factors contribute to a very small degree, but over millions of years, all of these factors kind of put together, especially tidal friction because of the Earth Moon interaction, that has collectively led to the gradual lengthening of the Earth's day from about 6 hours long to 24 hours, which we see today. So that's why the Earth's rotation is slowing down. Hmm.